Hello, I'm Ed Ackerman of Photonic Systems. This is a brief demonstration of the PSI 7500 interference canceller, which, as I will be explaining, employs what we call a self-generated reference to allow a radio to receive a low-power signal of interest even when high-power interfering signals are present in the same frequency band. Some interference cancellers use filters to isolate a signal of interest, which will not work in applications where interferers occupy that signal's same frequency band. There also do exist what we call reference-based cancellers that can suppress in-band interferers because they employ subtraction rather than filtering. Reference-based cancellers require the user to supply a copy of the interfering signals, and therefore such cancellers are suitable for some applications but not for others. Specifically, they are suitable only for applications in which the source of those interfering signals is on the same platform as the radio that's attempting to receive the signal of interest. The PSI 7500 interference canceller, with a self-generated reference, will recover signals of interest in not only those same platform applications, but also in applications where the source of the interference is not on the same platform and, therefore, no reference copy of the interfering signals is available. For this demonstration, my colleague Steve will be taking this Yaesu radio out of this room to generate the signal of interest that this second radio, also a Yaesu, will be attempting to receive. When he presses the transmit button, we will see a tone on this spectrum analyzer that's been set up to display all signals at the input to the canceller. And here you can see that setup. The canceller is connected to this antenna through a splitter that where one part goes to the canceller and the other part goes to this spectrum analyzer. Now Steve's voice will FM modulate the carrier frequency from the radio when we perform the demonstration, but then you'll only be able to see that until the point where I turn on this second chassis here that will generate an interference signal that's about 20 to 30 dB stronger than the signal of interest, and will hop around in frequencies right in that same band, straying only by about 5 kilohertz at most from the signal of interest. And you can see here there's no physical connection between the interferer and our canceller with self-generated reference. If there were, then it wouldn't be called self-generated reference. We're going to show you both a before and after, so it's that type of demo. For the before part, we'll have Steve create our audio signal of interest from out in the hall so that we'll only be able to hear him through the radios. And with the interferer switched off, we'll of course be able to hear Steve on the receive radio. And then we'll also be able to see the spectrum of his signal on this second spectrum analyzer that's connected in parallel with the receive radio using a similar splitter configuration there at the output port of the canceller. And when we turn on the interferer, it will completely drown out his voice and wipe out that nice spectral plot from before we have the interferer on. And then we'll do the after part of the demo. With the interferer still running strong, we'll turn on the interference canceller, and Steve's voice will then and only then again become audible, and his signal's spectral plot on the output spectrum analyzer will be restored. In other words, we'll be demonstrating that the canceller is performing as designed. So let's now do the before part of the demo. Steve's taking the transmitting Yaesu radio and heading out into the hall and closing the door and starting to repeat the alphabet until we tell him to stop. So we'll start with both the interferer off and the canceller off.
A, B, C, D, E, F, G,
so of course,
H,
with the
I,
interferer off
J,
and the canceller off,
K,
it's easy to hear Steve. And we can see the spectral content of the signal both before it goes into the canceller and when it comes out. And this is an old spectrum analyzer, so the screen is rather dim, but you can often see that this central carrier frequency where the dot is has some FM modulation on it caused by the audio of his voice. But now I'll turn on the interferer, and several things will happen. First, we obviously can't hear Steve anymore, even though I'm assuming he's still reciting the alphabet out there. And on the input spectrum analyzer, we see this much stronger frequency hopping interfering tone. And at the output, we see that what had been a signal of interest down in this region is now overwhelmed by interfering tones right nearby and much stronger. And now for the after part of the demo, though, let's turn on the canceller. And when we do that, his voice will come back. And at the output spectrum analyzer, the strongest thing is now the signal of interest right in the center there. You do see artifacts of the interferer, and you can hear some artifacts of the interferer. The cancellation is not perfect, but his reciting of the alphabet is clear enough to understand. And now I'm going to turn off the radio so I can conclude what I want to say and not interfere with his voice. We've demonstrated that the PSI 7500 interference canceller with self-generated reference allows a radio to receive a low-power signal of interest in the presence of high-power interfering signals, even when there's no reference copy of the interfering signal available to connect to it. Thank you very much for your attention.